There are 32 different flavors of ice cream at Raskin Bobbins. A double scoop cone consists of one scoop of an ice cream flavor placed on top of another scoop of an ice cream flavor. How many different double scoop cones are possible if the two flavors that are chosen are different? So there's actually a couple ways we could approach this question. And I'm going to go through both of them for you. Okay? Both of them, at least the two that pop into my head. I suppose we could also do something crazy like list them all out, but let's try and be a bit better than that, shall we? Okay? So one way to realize the answer is to say something like, well, if we want both of the flavors to be different, I guess we don't need the two different flavors. There's only two scoops, so either they're different flavors or they're not. And that's kind of my point. Different flavors is the same as not having both scoops the same. Okay. So one way to approach this question is to take the total number of all possible double scoop cones and subtract the number of double scoop cones with both scoops the same. Okay, so this is one approach. It's a perfectly good approach. So, let's first work out the total number of double scoop cones. So, if we imagine our ice cream sitting on top of one another, when we go to make our double scoop cone, first we'll dig into the flavors that we've got, and we'll pick out one of the 32 flavors for the bottom scoop. And then we are free to pick another flavor or the same flavor. We still have 32 flavors that we can choose for the top scoop. Okay, these choices don't affect each other. It's not an either or. These aren't different cases. Okay, so 32 times 32. And if we want to work that out, it's 1024, or I suppose you could just leave it as 32 squared. Okay, emphasizing that you've chosen twice from a collection of 32 possible things. Sort of a selection with replacement situation. Okay, so we'll have 32 squared minus, now we want the number of cones with both scoops the same. So the number with sort of a single flavor. So how do we do that? What does that sort of ice cream cone look like? Okay. So we pick our first flavor. We got 32 choices for the first flavor, but we have only one choice for the top one. It has to match whatever we chose for the bottom scoop. Okay? Or you can just think of this simply as 32 possibilities. Either it's all chocolate, or it's all vanilla, or it's all strawberry. Okay? So we've got 32 squared for the total cones. We've got 32 cones that we are not interested in. So our answer could be summarized as 32 squared minus 32. Or you could say 1024 minus 32 if you want to get the actual numbers involved. Okay? And so subtracting that would be 992. And another way to view this is you could factor out a 32 here and say 32 times 32 minus 1. So another answer would be 32 times 31. Okay? Perfectly good answers. Okay. But this isn't the only approach. We could actually compute this directly. Okay? You know, maybe we're here to practice our counting the opposite and subtracting from the total technique. Okay? Or maybe we want to practice something else. So instead, we could just compute it directly. How are we going to do that? Well, if we want the number with different flavors, okay, what are we going to do? First, we'll pick our first scoop. We've got 32 choices for that first flavor. Okay, but then when I go to get my second scoop, I want it to be different. So it can't be the same flavor, so I lose a choice. Okay, if I pick chocolate first, I can't have chocolate on top of it. You know, I can have gold medal ribbon or cotton candy or something else. Okay, so 32 choices and then 31 choices our first choice affects our next choice. And so in this way, we can see the answer should be 32 times 31, which we already pointed out was one way to write the answer. And if you want to, you can multiply that out and get 992, okay, the actual numerical value. Okay. So there's different approaches. This worked quite nicely, this 32 and then 31, because there weren't that many scoops and there wasn't really a whole lot else to the question. Okay. But it is also worth it to be able to understand that, okay, maybe we could count the total number of cones and subtract the ones we don't want. Because if there were a lot more scoops or there was a lot more restrictions on what cones we wanted and didn't want, we might appreciate this method. This might become easier. Okay. Either way, we get an answer of 992, or 32 squared minus 32, or just 32 times 31, however you want to state it.